Welcome back for some quotient rule goodness. And this one, there's a lot going on with this formula, but I'm going to try to really simplify that for you. So as you can see, we're going to be doing quotient rule. That puts us right here on our downloadable PDF derivative rules that you want to have access to. So quotient rule says if our function of x is a function of x divided by a function of x, the derivative is you take the bottom function times the derivative of the top function minus the top function as it is, derivative of bottom, and then you square the bottom. Well, that's a lot to remember. It'd be nice if we had some kind of silly poem that went with that. So I'm going to call my quotient g of x on h of x. I'm going to call it a low function. Well, that would be silly. And a high function, the high function on top. So we've got high over low. So if I call this one low, this high, and I refer to the derivative of the high as d high, the derivative of the low is d low. Here's what we have. We have low d high minus high d low over the square of the thing below. Low d high minus high d low over the square of the thing below. And as many years as I've been doing this, to this day, I at the very least in my head say that every single time I do quotient rule. So if that doesn't make much sense to you, I think it is about to. All right, let's get zoomed in here a little bit. So this is a function over a function. Function of x, yeah, it's like 5x to the 0th. This would be more typical of what we'd be looking at. There are actually other kind of sneaky ways to handle this, but we're going to do this with quotient rule for now. So that's f prime equals, and one time, I'm going to go ahead and write this all out. So it's going to be low d high minus high d low over the square of the thing below. Now normally I would just jump to this second step where I would say, well, it's low 4x to the 4th minus 3 d high, and we'll forget this from time to time, but the derivative of a constant is 0. Remember, a derivative is slope, and the line y equals 5 looks like this. What's the slope of that line? 0. So low d high minus high d low 16x to the 3rd, all on the square of the thing below, 4x to the 4th minus 3 squared. So this one's pretty easy because the simplifying, multiply by 0, I get 0, so we just end up with negative 80x cubed on 4x to the 4th minus 3 squared. And there is not much we're going to do to simplify that. Okay, so a nice warm-up problem. It helps when you have a constant in the numerator for sure, or any constants. We have like this 3. It helps to have a plain old 3, plain old 5. So here we go. I'm going to jump to step 2 with this one. F prime x, the derivative equals low d high, derivative high, 12x squared. Minus high, I don't know why I write so uphill, minus 5, minus high, low d high minus high, 4x cubed d low times 8x to the 3rd, all on the square of the thing below. I won't forget to do that. So we get, distributing for simplifying, 24x to the 6th plus 60x squared minus 32x to the 6th all on the square of the thing below for 6. 24 minus 32, negative 8, x to the 6th plus 60x squared, all on 2x to the 4th plus 5 squared. And oftentimes we're trying to find when this is equal to 0, so we would factor this. We'd factor out a 4 or a negative 4. We'd factor out a pair of x's, but we're going to leave our answer in that form for now. All right, number 3. Low d high minus high d low. Low d high, so that's low. D high, 5x to the 4th, minus high. D low, 12x squared over the square of the thing below. Distributing 20x to the 7th minus 20x to the 16th minus 12x to the 7th, all on the square of the thing below. For final answer, x to the 7th, I've got, did I seriously have a 16th here? What happened there? I have no idea. 20x to the 4th. 7ths, I've got 8 x to the 7th minus 20 x to just the 4th, all on the square of the thing below, 4x cubed minus 4 squared. And really tempting now to go ahead and reduce by 4. However, kind of sneaky here. If I was going to reduce this thing, I might want to think of this as 8x to the 7th minus 20 x to the 4th on 4x cubed minus 4 times 4x cubed minus 4. I can reduce a 4 from this factor, or let's say I factor out a 4. This would become a 1. And I can factor out a 4 from the top. Wish I'd redo that. If I factor a 4 out of the top, I get 4 times 2x to the 7th minus 5x to the 4th. If I factor a 4 out of one of these in the denominator, I get 4 times x squared minus 1 times 4x squared minus 4. Cancel a 4. And you could do that. I wouldn't be surprised if our solution has that as its answer. Okay. One more here on this page. F prime low D high minus high D low over the square of the thing below. And once again, uphill. Distribute 3x to the 5th minus 12x squared minus 3x to the 5th, all on the square of the thing below. X to the 5ths cancel. I get negative 12x squared on x cubed minus 4 quantity squared. So there's some fairly simple quotient rules, and trust me, they can get a lot nastier. These are going to have a little bit more going on, but well within our reach here. So y prime low 2x to the 5th plus 4. D high, low D high, that's 10x to the 4th minus high 2x to the 5th plus 5. D low, 10x to the 4th is D low as well, all on the square of the thing below. Distribute, I get 20x to the 9th plus 40x to the 4th. Danger time minus, have to distribute eventually, so I'm going to get 20x to the ninth here, but that'll be minus 20x to the ninths. And I get 50x to the fourths, but that's minus 50x to the fourth. All on the square of the thing below. So final answer, x to the ninths cancel. 40 of these minus 50 of these, negative 10 of these. All on 2x to the fifth plus 4 squared. And that's it. And that's what we'll be doing in this section. A little bit more going to be going on with number 6 because I don't have two constants up here. But we're going to go ahead and run through it. Y equals low, 5x squared plus 2. Derivative high, d high is 10x to the fourth minus 20x to the third. So that's low d high minus high 2x to the fifth minus 5x to the fourth. High d low 25x to the fourth. All on the square of the thing below. Equals. So now I'm faced with some foiling here. 50x to the sixth minus 100 x to the fifth plus 20x to the fourth minus 40x cubed. Again, have to be careful and distribute this negative. So this gives me 50x to the ninth. 50x to the ninth, 5x to the... Ooh, there it is. There it is. Another mistake, 5x to the fifth plus 2, low. That makes this 50x to the ninth. That makes this minus 100x to the eighth. Doesn't change this, doesn't change that. Whew. All right, minus 50x to the ninth, minus a minus plus 125x to the eighth, all on the square of the thing below. Wow. X to the ninths, 50 minus 50, that's nice, they're gone. X to the eighths, negative 100 plus 125, 25x to the eighth. X to the fourths plus 20x to the fourth minus 40x cubed, all on the square of the thing below. So once again, calculus easy, algebra hard, tedious, precision. I'm going to do a better job of being more precise on these steps. So y prime, the derivative is low. D high. Nice to have a constant and a constant. Minus high. D low, 15x to the fourth. All on the square of the thing below. Distribute 12x to the eighth plus 16x cubed. Don't forget to distribute the minus. I get 15x to the eighth, but it's minus. I get negative 30x to the fourth, but it's the opposite of negative, plus 30x to the fourth. So x to the eighths minus 7x to the eighth. X to the fourths, got some here, plus 30x to the fourths, and a plus 16x cubed, all on the square of the thing below. And if I had that set equal to 0, I would at very least factor out an x cubed. Okay, if you have not tried one, this one's fairly friendly. Again, we have two constants, which helps us out a little bit. Go ahead and give it a shot. Y prime is low, 3x squared plus 5. D high, 16x to the third, minus high, 4x to the fourth plus 2. D low, 6x. All on the square of the thing below. Distributing, 48x to the fifth, plus 80x to the third, excuse me, minus, distributing the minus, I get minus 24x to the fifth, and the most common mistake right here would be to have plus 12x, but it's minus 12x, all on the square of the thing below. For final answer, fifths, I've got 24x to the fifth plus 80x cubed minus 12x, all on 3x squared plus 5 squared. If this was set equal to 0, we could factor out an x, and it looks like we could also factor out a 6. Oh, can't factor out a 6. Can certainly factor out a 2, though. Can factor out a 4. We can factor out a 4. Okay, so I do believe that's probably would be the answer on the solution guide. So there you have it. That is 17 minutes. If it takes you half an hour for the assignment, which probably will not after seeing this, you're looking at about 45 minutes. So not too bad for a one-day lesson.